team, just want to work through some of the simultaneous equations stuff now. So just going to work through this one. So it's three equations that we're going to have to pop into a matrix and work through to solve. So we've got 5x minus y plus 2z equals 1. Then we've got negative x minus 3y equals negative 5. And then we've got x plus 5z equals 19. So now these empty spaces are going to need to have placeholders in the matrix, so we'll just use zeros in place there. So I'm going to go ahead and create my first matrix. So I'm going to work through my top equation first, so that'll be my first row. So I'm just going to take the 5. So now here, I just want to highlight this part. So it might just look like that we'd put a 0. A couple of people may make that mistake, but it's actually negative 1 because there is a y, and we do take the negative symbol. So ensure that you're using the negative 1 there. And then for the z, it'll just be a 2. Jumping down into our next row, again, same as the y. This one is a negative 1 for the x, negative 3, and then this is where we'll need to use our 0 placeholder, just like that. Again, jumping down into the third row, we've got a 1, because there is a 1 there. There is 1x present. Again, another placeholder with a 0, because there are no y's in this equation. And then we move on to the z, where it's multiplied by 5. So that is our first matrix, and I'm going to call this one A. I'm going to keep it separate, so I'm not going to go x, y, z, because we've already got those used in our matrix. So then, of course, as we would work through with multiplication, we're not simply going to have x, y, z across in one row. We're going to have to go down in a column due to the nature of multiplying matrices. So I'm going to go x, y, and z. And I'm going to call this one B. And then we go over into our answers column. And of course, because this one is a 3 by 3, and this is a 3 by 1, the middle numbers indicate that we can multiply this through, and then the numbers on the outside indicate the order of the answer matrix. So it's a 3 by 1. So 3 rows, 1 column, so it will be the same as our column containing our x, y, and z, and we just take this from the answers here. So 1, negative 5, and 19. So that's completed the step where we are creating the different matrices. So then we need to solve this. So given what we know that A times B equals C, of course. And as with any work that we're going to do with numbers, we want to get this B part on its own. So we've had a look at how we would do this in class, and I just want to run through it again. So remember that we can't just simply divide matrices, we have to multiply them by the inverse. So we're going to be using the inverse of A. So we would be going the inverse of A multiplied by C. Now remember that that is because of the order issue. So the inverse of A is going to be a 3 by 3, and we're going to multiply it by C, which is a 3 by 1. If we went the other way, it's going to be a 3 by 1 multiplied by a 3 by 3. And of course you can see that because the numbers here are different, it's not going to work. That's a simple check to do, but if you look at it, you can't take the top row and multiply it by the first column because they're not the same. So we're going the inverse of A multiplied by C, and remember what we do to this side we have to do to the other side. So the inverse of A multiplied by A multiplied by B. Now right back at the start of looking at the inverse, we learnt that these here, so the inverse of A multiplied by A will actually give us the identity matrix. So it's the identity matrix multiplied by B equals the inverse of A multiplied by C. So again, we learnt that the identity matrix was the matrix equivalent of the number 1. So anything multiplied by the identity matrix will simply be itself. So we're left with B, which is what we wanted. We wanted B alone on one side of the equation equals the inverse of A multiplied by C. So my suggestion is that this is the key that you need to remember. This all just explains how we get there. So that last equation is what you really need to remember, and you really need to keep it in your mind that it is the inverse of A multiplied by C. That's the order. You need to understand, if you're getting errors on your calculator, or if it's just not happening for you, check the order of your matrix. So I'm just going to plug that into my calculator because, of course, we haven't got to the stage where we're finding the inverse of a 3 by 3 matrix. We're simply working with the 2 by 2. So I'm going to switch over to my calculator now, and I'm going to enter that matrix. So, of course, 3 by 3, I can just leave it simply like that. So it was a 5, -1, 2, my first row. Second row will be -1, -3, and that placeholder 0. Then we've got a 1, 0, and 5. So yeah, 5, -1, 2, -1, -3, 0, 1, 0, 5. Beautiful. And of course, as I did on my written page, Control var, and I'm going to save that as matrix A. Slow computers tonight. Excellent. So I've got my A in there. My next matrix was, of course, my C matrix, which was my answer matrix. So opening that up again, and that was a 3 row by 1 column, and that was 1, -5, and 19. And that one I'm going to save under C. So I've got both of my matrices saved in my calculator now. And all I'm going to do to get my answer for my X, Y, and Z is I'm going to go my A to the power of -1, which of course is the inverse. And that I'm simply multiplying by my C matrix. So what that essentially means is that, so if we take that information, what it's telling us when it comes up is that X is equal to -1, Y is equal to 2, and Z is equal to 4. So you just read it across from where your X, Y, and Z are in that B matrix. So that's simultaneous equations with matrices.